Hello, everyone, and welcome to the Weekly Space Hangout for Friday, November 18th, 2016. I'm Fraser, Cain, publisher of Universe Today. This week, we've got a bunch of cool stories for you. We're going to be talking about more new information about Pluto, the launch of the GOES-R weather satellite, more information about the bright spots on Ceres, and a really cool feature found on Mercury, which is apparently getting smaller. Joining us this week, and we've got a very special, we're going to do sort of an extra long special on Tabby Star, aka the alien megastructures. We will get to the bottom of it today on whether or not it's actually an alien megastructure. We will, case closed. All right, joining us this week, we've got Kimberly Cartier. Kimberly.
Hey,
Welcome.
Fraser. Hello, viewers.
We've got Morgan Renberg. Hey, Morgan.
Happy Friday, everyone.
Yay. And our special guest, which is Dr. Jason Wright from the same place that Kimberly comes from and works with her on this research. Jason, welcome to the Weekly Space Hangout.
Thanks. Good to be here.
I didn't bring you up. Okay, so Jason, let's talk about so your research. Actually, before we do, why don't you explain sort of who you are, sort of what you're working on, and then we're going to get to the meat of this episode, which is we're going to be talking about alien megastructures, or maybe not. I don't know. Who knows what my whim, where I'm feeling. So Jason, where are you at?
So I'm at Penn State University. I'm an associate professor here. I work with Kim Cartier, and most of my bread and butter research is actually finding planets orbiting other stars and studying those stars to learn more about what it might be like to be on one of those planets. But sometimes, just sometimes, I go off and work on SETI stuff, search for extraterrestrial intelligence stuff. And lately, that's kind of taken over my life in the last few months.
But I guess in this case, right, the two have come together. That you've been looking at other planets, observing those, and then at the same time, this sort of the whole SETI part has kind of creeped into the story as well. So now we've talked about Tabby Star, about the alien megastructures quite a bit, but just in case people haven't, can you just give us another setup on sort of what was discovered and kind of where we stand right now?
Yeah, sure. Do you have those the figures I sent so we can?
No.
Viewers know.
No, but I will dig them up. Did you email them to me, or were they part of the?
Yeah, I sent those. I sent those along earlier.
Okay.
I can describe it. The Kepler space satellite, NASA launched a telescope called Kepler, up not even in Earth orbit, out into the solar system. And it was designed to look for planets around other stars. So it just stared at the same patch of sky for about 4 years, stared at something like 100,000 stars. And it was hoping that some of those stars would have planets around them whose orientations was just right, so that the planets would pass in front of the stars once every time they went around. And whenever that happens, the star will get just a little bit dimmer. So if it's a planet like Jupiter, then the star might get around 1% dimmer. And that you can kind of detect from a ground-based telescope. In fact, it's the kind of thing that even amateur astronomers can do with backyard equipment. But if you want to find something like the Earth, it's much smaller, and so the star gets much fainter, hardly fainter at all. And that's what the Kepler Space Telescope was designed to spot, these planets the size of Earth passing in front of their stars. So it found a lot of things. It turns out stars vary in brightness for lots of reasons. Sometimes other stars pass in front of them. Sometimes they're variable stars. Sometimes, there's a lot of things that can happen. And it's a huge amount of data. 4 years of brightness measurements every 30 minutes on 100,000 stars is kind of more than astronomers can look at. So in addition to computer algorithms, which sifted through the data looking for things that look just like a planet, citizen scientists called planet hunters would go to the Planet Hunters website, just ordinary people, and just look at the light curves, look at the data, and see if they could find things the algorithms missed. And it turns out they found a lot of things the algorithms missed. And there was one in particular that was just stranger than all the other ones. Let's see, do we have those? We could, at any rate, there's this one star that would get dimmer in a way that didn't look anything like planets. So a planet might make a star 1% dimmer or less for a few hours. But this star would take a couple days to get dim and then bright again. And it would do it in patterns that don't seem to make any sense. A couple times it got 10, 15, or 20% dimmer than it had been before, and then suddenly just snap back to its normal brightness. It's the only star in the Kepler field that does that ever did that. Sometimes it would go for a whole year, not changing brightness at all, and then right before Kepler had to look away, it just had dozens of these dimming events where it got much dimmer. So we're still trying to figure out what's going on and what's so special about this star, because in almost every other way, it appears to be just an ordinary star hanging out, a little more massive than the sun, a little hotter than the sun.
So, I mean, the joke that's been running around all this time is, I'm not saying it's aliens, but it's aliens.
Oh, you would not believe how many times I get that meme.
I think I would.
Yeah.
In fact, I probably have been one of the ones making that joke as well.
There you go. You're one of the ones saying that.
Yeah. But I guess what's important is that in most situations here, we can rule out some of, aliens are the most ridiculous possibility, and normally we can rule out this kind of thing. Mm-hmm. Can we rule them out yet?
Well,
and if it is aliens, what is
I answer the question the other way around.
Okay.
So, we see weird stuff in the sky all the time. All the time. There's space junk floating around the Earth. There's flashes of light from across the universe, from exploding stars or other things going on. And then instruments have weird hiccups all the time. There's a famous wow signal from radio SETI that they were pointing a telescope at the sky, and there was this very bright radio flash apparently from space. It's never repeated, never seen it again, don't know what to make of it. Maybe it was just a glitch in the equipment, who knows? So weird stuff happens all the time. The question is, can you go back and see it again? Are you sure it's really there? And could it be something totally mundane or otherwise natural? So the question isn't really, can we show it's not aliens? I mean, who knows? Aliens, whatever. They can do whatever they want. How can you show anything's not alien? How can I show you're not an alien, right?
Yeah.
The question is, can we rule out everything else? So I think of aliens as a hypothesis of last resort, because I don't know how to test that it is, except maybe getting radio communication from them. But I think we can check for everything else it could possibly be. And so, no, we haven't ruled out natural explanations for what's going on.
Well, I guess what are the natural explanations that you've been able to rule out so far? Or what is left?
Yeah. So when this was originally found, the first instinct all the astronomers had, was there was something wrong with the spacecraft. And I think NASA has basically ruled that out. Lots of teams have looked at the NASA data, and it makes sense in every way except that it's the signal is weird. But it's not a problem with the detectors. It's not a problem with anything here. And then the astronomer that originally did the analysis of this star spent years showing that it wasn't a glitch, that it wasn't anything ordinary. That's Dr. Tabitha Boyajian, and she's now at Louisiana State University. She ruled out that it's the next most obvious thing, which is that there's a class of very young stars called dippers. And these are stars that are still sort of forming. They have disks of material around them that are kind of feeding the star, and the leftover material in those disks 100 million years from now, or tens of millions of years from now, will form planets. And if we see those disks edge on or almost edge on, then sometimes they'll bump up in front of the star, and we'll see things kind of qualitatively like this, not exactly like this. The problem is that this star, Tabby star, it's not young, and it's not. It doesn't show any evidence of a disk, and that's what makes it so weird. Is there doesn't seem to be anything around it that could be explaining this. So we're pretty sure it's not a disk, because we don't think it should have one, and we don't see any evidence for it. And then Dr. Boyajian's next best idea was giant swarms of giant comets. And when the comets go in front of the star, they make the star dimmer. That's a little hard to. It's a little harder to believe now, because there have been two studies, one using the Kepler data itself, that have shown that the star just keeps getting dimmer overall, and that at the end of the Kepler mission, it was 3 or 4% dimmer than it was at the beginning of the Kepler mission. And stars don't do that. Like, that's a second very strange thing that Tabby's star is doing in addition to the dips. And there's no reason comets should do that. So, okay, yes, maybe comets for the dips, but then why the long-term dimming? So I think that's not enough, even if we haven't ruled it out. So then we're left with just really unlikely scenarios. We were thinking something in the interstellar medium. There's clouds, nebulae, gas, dust in the interstellar medium. Maybe sometimes it forms a really rare cloud, something really dense, really small that we hadn't noticed, and that just is passing between us and the star. Maybe that could do it. But that's little more than just the words I'm saying. Like, we don't have any evidence for such a thing.
Right. I mean, that, if I recall correctly, there has been sort of work done to sort of go back in other observational data and take a look at the star, and indeed you can kind of correlate that in fact there have been, that dimming has happened, or some kind of dimming is happening in data that has nothing to do with the Kepler data. So it's
right
being seen
right.
in other places, right?
That's right. So the long-term dimming was first spotted with archival photographic plates. Harvard College Observatory had been taking photographs with glass plates of the entire sky every few years or more often for over 100 years. And if you look at those plates, an astronomer named Bradley Schaefer actually went to the plate stacks, dug them out, put them on light tables, put a jeweler's loupe on, and measured by eye the brightness of the star for 100 years. And it's been getting dimmer for the past 100 years.
Right.
And so something weird is definitely going on.
So, I mean, we've definitely talked about this quite a bit here, and all the viewers are fairly familiar with the story so far. We're a year into the discovery at this point?
A year. That's right.
What is the state then? What is the sort of most current state of what the majority of researchers think this probably is?
Oh, I think the current state of the majority of researchers is just a big shrug. I mean, there was just a big conference where experts in these Dipper stars got together and talked about all the Dipper stars and all the stars with disks and how to categorize them and just really work it all out. And Dr. Boyajian actually gave one of the keynote addresses at this conference about that star, and the collective consensus was, this doesn't make any sense.
Kimberly, I don't know sort of where you stand. Do you agree that it's just a big shrug at this point?
At the moment, yeah. I mean, like Jason said, there are some theories that could still work if we had any evidence that those things actually happened. But given all the observations and all the data that we have right now, I mean, nothing natural seems to explain anything right now, given what we know. We could get more observations later that would say, oh, there's that cloud that we missed the first time. But there's my shrug to add to the list.
Perfect. We just collect them all.
Well, remember, nature is cleverer than we are. And so there's a lot of stuff out there, right? More things on heaven and earth, than we've thought of so far. And so we're trying to be clever and think outside the box. So we had an idea that maybe a black hole drifted between us and the star. And a black hole would actually make the star brighter, not dimmer. But if it had a giant disk around it, then maybe that disk is blocking the starlight. And you have to say it's a black hole in the middle, or else you'd see it because it'd be a star and it would be bright. Black holes aren't bright, they're dark, black. So maybe that could do it. But I mean, we're really, really stretching here because we don't even know that those black holes have disks so that there's enough of them to do that. So, yeah.
I got a couple of questions coming in from the viewers, so we'll throw a few easy ones first. What class star is it? This comes from Arjun.
It's an F3 star.
And so for people who don't
Oh,
have their
right.
chart
That's
in
a
front
little
of them.
hotter than the sun. There's basically two classes of stars, hot stars and cool stars. And the sun is about as hot as cool stars get, and this is about as cool as hot stars get. So it's just on the other side of the line. If you could see it, it would look a little bluer than the sun, or a little whiter, I guess, than the sun. But it wouldn't have all of the, you see pictures of the sun and it's kind of boiling on the surface with star spots and stuff. It wouldn't have those. It would be very, very smooth.
Okay, a couple of people thinking maybe sunspots.
Right. So it shouldn't have sunspots, but also We know that it's spinning very fast.
But
goes
could
around
it be
about once a day.
sunspots? I guess is the question.
No, right. No, because it goes around about once a day. So if you put a big star spot on Tabby's star, then it will make the star get dimmer about once a day. But these dimming events are, days long. In one case, it's over a week long. And it should be going up and down every day as the thing goes around the star. And so anything on the star itself should show that modulation about once a day. And the big dips don't.
ML Robinson's wondering about pulsars. Is it somehow a pulsar involved? No?
No.
Okay.
Well, what about pulsars? No.
Definitely
Pulsars,
not a pulsar. Like, you would
right.
definitely know
Right.
that it wasn't a pulsar.
Pulsars are very small, and you don't mistake them for stars, and they're also very massive. They're more massive than the sun. So if something that massive were near Tabby's star, it would be orbiting. Tabby's star would be orbiting it, and Tabby's star isn't orbiting anything. It's just sitting still, basically.
Okay, hold on. We got some more here. Yurko Roberto, could the star be in or close to a nebula?
Normally, you can see nebulae. So that's sort of one of the ideas we had, that maybe there's a nebula between us and the star, and it's cold, so you don't really see it lit up at all. So that's sort of like the idea we've had, that there's some kind of cloud between us and Tabby's star. But remember, there are nebula everywhere. I mean, there's gas and dust everywhere in the galaxy. Every star you look at, except the very closest ones, you're looking through dust and gas and nebulae and stuff like that. But this is the only one that does that. So the argument's always been, if that were a thing, this wouldn't be the first time we'd seen it. We've known about it for 100 years.
Right, so you would see this in other places as well. Right, okay, all right. Hold on, we got some more ideas here. Clearly this is just like the same conversation that goes on at the conferences when you guys get together. Shingiri wants to know, how much bigger is Tabby's star than our sun? You say it's a hotter star, which means it's more massive. It's a little bigger.
What did we decide, Kim? 40%?
Okay.
Yeah, 40%.
We said 40% bigger.
And 50% more massive.
Okay.
Yeah, something like that.
Now, I know this is sort of a long shot, but people have turned their SETI observations at Tabby star, and so far no interesting signals.
Right. So you got to look. Yeah. I mean, if what you've got here are giant things blocking the starlight that really are around the star, then it's possible that if something built those, if aliens built those, that they might also transmit radio waves. And so you got to check. We've got some really, really sensitive radio telescopes here on Earth. And actually, Kim and I were just down at Green Bank Observatory a couple weeks ago. And we pointed one of the largest radio telescopes on Earth right at it and checked lots and lots, billions of frequencies to try and to see if anything's there. We haven't finished studying the data yet, but we aren't sitting on anything. We haven't analyzed the data yet. That's basically what's going on.
So currently, if I understand this correctly, we are at, you have no idea, every natural thing that trained stellar physicists have been able to think of have been ruled out, and no evidence has been able to be found to support it. You can't rule out aliens yet. It's just a big mystery. Yeah. Have any other objects been found that are similar to this star?
Yeah, there are these other Dipper stars. But in every case, the star is either obviously has a disk that you can see it in other ways, from the heat the disk gives off, or the star is obviously young because it's among many other very young stars. And so it makes sense. There's no reason to think anything strange is going on. It's really interesting. That's one of the things this conference was about, that Tabby was at. But this star just doesn't show any evidence that it could be young. And that's what's hard. It's really hard to understand how it could be a young star. But all that said, this is a rare event, right? We've got over 100,000 stars. It's the only one. So I think that means that the explanation is going to be something inherently unlikely. So when these ideas come up and we're like, yeah, that doesn't happen because of this and that. Well, what about 1 in 100,000 times? Could it happen? It's clearly something weird. So that's probably one of the reasons it's so hard to think of the right answer. Is it
Right.
probably involves a whole bunch of unlikely things strung together.
1 in 200 billion, for example. Right?
It's one in more like 200,000.
Oh,
We
okay.
haven't checked all the stars.
You haven't
yet.
checked all the stars yet.
200,000.
Okay, fine. So let's imagine that someone writes you a blank check for some kind of either specific study or brand new tool. Go ahead. You can launch your own satellites. You can you can direct the gross domestic product of most of North America towards trying to get to the bottom of this mystery. What would help you kind of take your observations to the next level and try to sort of get a little closer to the answer?
Well, one thing I would really want to know is exactly how far away the star is. One thing is, it seems to be getting dimmer, but maybe that's the wrong way to think of it. Maybe it's actually too bright, and it's coming back to normal, that something's going away, not something's going in front. And so knowing exactly how far away it is would let us compare its apparent brightness to what we think its true brightness should be as an ordinary star, and tell us if that's what's going on. It'll also tell us the total amount of dimming. I mean, if it's been getting dimmer for the last 100 years, how long has that been going on? 500 years, 1,000,000 years, who knows how bright it's supposed to be. So that would help. Fortunately, the European Space Agency did that a few years back. So we have the Gaia spacecraft up there measuring its distance as we speak, it along with a billion other stars or something. So we'll get that answer pretty precisely in the next few years when they analyze those data. And then the next thing I would do at the lower price point would be just watch it. Just point ground-based telescopes at it for a whole year and see when it gets dimmer again. And if it has another dip, gets 10% dimmer, then just swing everything we've got at it and measure the spectrum of the star. Because if it gets 10% dimmer, something's changed. And so we can then study the star's light and see, is dust blocking the light? Did the star get cooler? Is gas blocking the light? Did all wavelengths get evenly dim, like something's blocking it? And that's something that we're in the midst of. So Tabby herself, looked into it and found that she could purchase private telescope time to do that with about $100,000. And she sort of short-circuited the normal proposal process. This is really kind of a long-shot project. It's just one star. It's not the kind of thing that we would have high hopes of getting precious federal dollars for. And she kickstarted it. And got the 100,000, and now she's monitoring the star. And so, I get alerts like we think something might be happening. No, it was a bug in the software. And if it really does start getting much dimmer, we're going to send out a whole bunch of alerts. We've hot wired, as they say, the Swift satellite, which we run here at Penn State, to swing around and check it out as soon as something happens. And that's what I would do next. So I would do basically what we're doing.
Right. No gigantic blank check required. The tools are at your disposal.
I mean, I'm sure I could think of something. But...
Yeah. But I think that's amazing and fantastic, and sort of shows to a degree that I don't think I've ever seen before that the public is super excited about the research being done, and they were willing to write checks and to contribute their money to help get a little closer to an answer to this mystery, which, in my other life, I'm one of the directors of CosmoQuest, and I watch Pamela go after grant applications and the lengthy journey that it takes to try and raise that kind of money. But to be able to turn around and go, here's a big mystery, we need help. And for just the public, the science fans to step forward and help get to the bottom of this mystery is a wonderful thing. And I hope it sets a really great precedent for some of this kind of work in the future that normally I think people just expect that their tax dollars are going to find its way slowly to the research, but the reality is there may be other ways to help fund this stuff directly. So I think that was one of the most interesting things that kind of came out of that Kickstarter, that it came together so quickly and it happened. I'm really excited about that. Man, I was hoping that you would really get to the bottom. Okay, you know what? We're going to go to the next level then. Alien megastructure. If it is an alien megastructure, what kind of alien megastructure would it be? I'm thinking like partial Dyson cloud. What would produce that kind of a light signature?
Okay, so if you want to know what would, okay, so you need it, for some reason it's getting dimmer slowly, like a couple percent every decade,
Right.
something like that.
So they're working on it. They're
And that's
building it.
real slow. Well, I mean, my best model is that it's not that you're like slowly blocking more and more of the star, because stuff orbits. It'll, if it's going to start to block the star, it'll block it out completely at some point. And you're not going to build giant structures. Like, it makes a lot of sense, I think, to build solar panels in space. We do it for our spacecraft. Solar panels in space, great, that makes sense. But building a giant sphere around a star just doesn't make any sense. Why would you do it? It's not stable. It would fall apart. There's no material that we've ever heard of, including like neutron star matter, that could support it and be stable. It doesn't make sense. So I imagine that this would be more like a cloud of solar panels. So space is really big. Like, the solar system is enormous. And even a huge solar panel, like the size of a building, on the scale of the solar panel of the solar system, is just like a little speck of smoke. So even if you had lots of building-sized solar panels all over the solar system collecting sunlight, from a distance it would just look like smoke around the sun. And that would make the sun a little bit dimmer. And so if you kept adding more and more solar panels, or a big swarm slowly came into view, that would make it seem to slowly get dimmer. So maybe that explains it. And then the big dips, I guess, are just giant planet-sized formation flying of these things.
Sounds good. No, I mean, building a Dyson cloud is hard, and it's going to take some time. So it makes sense that they won't have the project finished overnight. It's going to take them a little while. So I guess my last question I'd like to know is that really the success of this story, for me as a journalist, as a publisher, as an editor of the, watching the traffic on the website, it was the aliens that really gave this power and gave this a lot of energy in the, towards the audience, really captured their imagination.
Right.
If it was just like, here's a star and it's doing something weird and we definitely know it's not aliens, but, could be like maybe there's a nebula passing in front, it wouldn't have gotten necessarily the same kind of like. So, did how this story capture the imagination and kind of run as far as it did? Did you guys as researchers kind of learn any lessons about that?
Yeah, we had to learn how to ride the bull. It was hard. I mean, a lot of media outlets are just going to do what they need to do to get your clicks, and then it's just a bidding war of ridiculousness in the headlines, and you just gotta do what you can. I tried to talk to as many reporters as wanted to get quotes and stuff to try and keep it sane, to try and tamp down on the more irresponsible reporting, and keep perspective going with the whole thing. I mean, that's when Tabby did the Kickstarter, she was really careful to point out this is not a SETI project. We're not looking for aliens. We're trying to solve a mystery that's presumably natural, and people still kicked in. So I mean, the aliens got people's attention, but I think people are really interested in the science behind it. I don't know. We do have to solve this problem, though, of how to have a sane conversation about extraterrestrial intelligence and that possibility. Because if every time someone tries to talk about it, the tabloids run with it and blow it up, and I'm not saying it's aliens, but it's aliens, then we're just not going to be able to do SETI, or at least we'd have to, can't talk to the public about it. So my hope is that we can kind of educate the media, educate the public about what SETI is and isn't, and model how to have a realistic conversation about it.
Where do you think we stand in this sort of search for extraterrestrials? With all of the different lines that are going right now, we've got the listening, the radio methods, the optical SETI methods. We've got, the sort of really exciting work, things like directly observing exoplanets. Kimberly was talking about this last week, that, that ground-based observatories are now starting to be able to observe exoplanets. So how long until we either can sort of know there are aliens or feel pretty confident there aren't aliens out to a pretty far radius?
So a long time, I think.
Hundreds of years? Dozens of years?
Well, I mean, part of it depends on whether we try. So for the last few decades, a few people have tried really hard. But by few, I really mean like a dozen. The SETI community is small, and the funding is all but non-existent. So a few really visionary people with resources like Paul Allen and now Yuri Milner and Barney Oliver, put fortunes into making sure that this is something that actually happens. And without that, we really wouldn't be listening at all. So part of it is that we haven't really tried, and maybe I'm just pessimistic that the governments that fund science will turn the spigot back on and allow SETI to have its fair share, some sliver of research dollars, and it won't all be privately funded. The second thing is, we're not obvious. If we were looking at the Earth, even if the Earth were around the very nearest star to the sun, I'm not sure how we would detect ourselves. So you have to hope that they're doing something to catch your attention, that they're exploiting the fact that they're presumably a billion or billions of years more advanced than us to do something really amazing, light that bonfire, put out that search beacon, send those radio signals that we'd be able to detect. Now, that said, we can detect our own technology if we try. So we can send a radio signal, and we have, strong enough that we could detect it with our own technology around a nearby star. But you'd have to know what frequency to listen at, you'd have to know when to listen, and you'd have to know where to point your telescope. So if you're just doing a blind search, how do you know? And so all you can do is search and hope that they're broadcasting.
Right. It's tough. Well, Dr. Wright, thank you so much for joining us this week on the Weekly Space Hangout. And of course, we've got Kimberly Cartier here as one of the regular team. So any of the research that you guys all uncover, we'll be able to get our hands on very quickly and be able to disseminate it. So I really appreciate everything you're doing. If people want to keep going and follow this for themselves, where can they find out more?
I try to keep people up to date on my blog. I usually tweet those out at Astro Wright on Twitter. It's Astro_Wright. But if you look for the Astro Wright blog, you'll see that. And I know Kimberly also sends things out when stuff happens, so they should follow her too.
Yeah, we talk about it every week, whether or not it's one of the topics we're going to be talking about this week. So yeah, the moment she hears anything, I know she'll bring it to our attention. Right. Well, thank you so much for joining us at the Weekly Space Hangout, and good luck with the research. We're all rooting for aliens.
Great, thanks.
All right, let's move on. So just want to remind everybody that this is a live interactive experience. So if you want to join the conversation, go ahead. We do this show live every Friday at noon. There's the YouTube chat, which is part of the live stream, but also there's this really cool Slack chat, which is down here at the bottom. And this is the WSH crew, the Weekly Space Hangout crew. And these are really the producers who behind the scenes of the show, who bring together our guests, who suggest a lot of the stories that we cover. This is their show. And we couldn't do this without the partnership of this wonderful community. So if you want to take your love of space and astronomy news to the next level, join the crew and get access to the Slack and join the conversation. They would love to have you join them. And I'm sure at some point someone's going to provide some. There it is. There's some instructions on how to join the chat and join the community. So just go to the wsh-crew.net website. All right, let's move on to some of the stories. And Morgan, let's start with talking about Pluto.
Yeah, well, it's been more than a year now, well over a year, since New Horizons flew through the Pluto system. And that means that scientists have finally had enough time to start sort of digging deeper and drawing more complicated conclusions than just sort of the surface level things that you could see from the images. And of course, one of the most striking things from the imagery that was returned on the day of the flyby was this big heart-shaped area on the side of Pluto that the spacecraft flew by that became known as Sputnik Planum. And it's extremely smooth. It seems to be very young. And what we've discovered since then is that it's very peculiarly oriented. If you were to start at Pluto's largest moon, Charon, and draw a straight line from Charon through the core of Pluto, that line would pop out right in the middle of Sputnik Planum. And obviously something as striking as that jumps out as probably not being a coincidence. And it turns out that there are good physical reasons that you can have arrangements like this. And they tend to have to do with when the density of your planet isn't constant. So if you have an area of a planet that tends to be relatively underdense, light compared to the rest of the surrounding material, that area tends to drift up to one of the poles of the object. This is why there's this enormous impact crater on the south pole of the moon. Conversely, if you have an area that's extra dense in your object, that tends to drift until it's oriented at the equator of the object. And this is for various physical reasons having to do with the way that forces act on rotating bodies. If you have a perfectly spinning sphere, you can rotate it around any axis. But if you have something that's asymmetric, you can imagine that there's some rotations that are preferred over others. And so this is telling us that probably this area of Sputnik Planum is denser than the rest of Pluto. And sort of immediately, this is not a shocking result, because Sputnik Planum is made up of nitrogen ice. And at these extremely cold temperatures, nitrogen ice is actually denser, it's heavier than water ice, which is what makes up most of the structure of Pluto. But in order to have enough of a density difference, in order to change the rotation of Pluto, Sputnik Planum would need to be something like 40 or 50 kilometers deep. And we actually think that it's probably more like 5 to 10 kilometers deep, based on other independent observations. And so this is suggesting that we have this dense area, and nitrogen ice is not sufficient, at least in the quantities that we think are there, to cause that. And so that's caused people to look for other explanations. And one explanation that seems to fit the need pretty well is the idea that localized under Sputnik Planum could be an ocean of liquid or semi-liquid water. And it's unlikely that it's sort of liquid like Earth's oceans are, or like we think the ocean under Europa or Enceladus might be. It's probably a lot more like slush, where it's this sort of mixture of partially frozen ice along with water, and it kind of sloshes around. But even that would be tremendously difficult to maintain this far out in the solar system. Pluto's a lot smaller than the Earth, which means it has a lot less heat inside of it in order to keep water melted and flowing as liquid. But we do think that sort of 2% of Earth's heat that Pluto might be able to retain would be enough to support a liquid water ocean if you had filled that ocean with sort of antifreeze elements, things that lower the freezing temperature of water. And, on Earth we have this. The oceans are full of salt. And this is why the oceans don't freeze when lakes and other things like that can freeze. But probably at a place like Pluto, the antifreeze is most likely to be ammonia. And ammonia is a really simple compound. It's a connection between hydrogen, the most common element in the universe, and nitrogen, an element we know there's lots of right there in Sputnik Planum. And you put those together, you make NH3, which is ammonia, and ammonia is extremely effective at reducing the freezing point of water. And so if you were to go and land on Sputnik Planum and drill down 5 or 10 kilometers, you might eventually reach this kind of semi-solid icy substance that it flows kind of like water flows, but just much, much more slowly. And if you were to pull some of that out and run it through a lab, you would find water and you'd find a bunch of ammonia.
It's really interesting that, because we know those other elements, those other chemicals are out there in the outer solar system, those ammonias and methanes and things like that. I mean, we can see them on the surface of Pluto, and to sort of imagine them mixing together to produce this antifreeze. I mean, could that help explain, maybe some of the prevalence of liquids in some of the outer solar system? Is it possible that this is happening in other worlds as well?
Absolutely. We're pretty sure that in order to maintain the liquid oceans underneath Europa and Enceladus and some of these other moons, that you have to have these antifreeze elements. And it doesn't always have to be ammonia. For example, inside of Europa, also sometimes invoked for the water that might be flowing inside of Mars, are these things called perchlorates, which are kind of salt that is just much more intense than your sort of basic sodium chloride ocean water table salt. And so depending on what the object is made of, you can concoct a whole bunch of different stuff that lowers the freezing temperature of water. And so at every one of these objects, it might be a different compound that's providing this effect. But space is really cold. I mean, incredibly sort of mind-bogglingly cold. And the only way to maintain an ocean, even in the presence of like a direct heat source in these places, is to lower the temperature at which water freezes. And so we think that's very common in the solar system.
Fantastic. It's nice to see that. I mean, this is sort of part of this whole thing with New Horizons taking so long to get all that full data back to Earth. The discoveries are sort of trickling out over long periods of time as they're able to analyze it as the high quality pictures finally arrive. I mean, they only just finally got here like about a month ago from when New Horizons had gone a year and a half ago. It's taken that long to finally get to us.
Yeah, we got years of these kinds of fascinating discoveries about Pluto ahead of us.
Yeah, fantastic. All right, Kimberly, we only talked a little bit about alien megastructures, so I think we're good. We covered that, but so let's move on. Let's talk about Ceres first.
Great. This actually ties in rather well with the Pluto story, I think. So I think one of the most underrated space missions that's currently actively taking data, is the Dawn mission, which is currently in the asteroid belt in orbit around the dwarf planet Ceres. The Dawn mission launched in 2007. It first visited one of the largest asteroids in the asteroid belt, Vesta, to take a look at that, and then it moved on actually and has been in orbit around Ceres since 2015, completed its normal mission lifetime in July, and has entered its extended mission. And it is still doing very well and giving us amazing images of these dwarf planets in the asteroid belt. And if you recall back a few months ago, maybe even a year ago now, as Dawn was approaching Ceres, it's a nice dark asteroid, dwarf planet, whatever you want to call it, in the asteroid belt, but there was one very bright spot on the surface that no one had any idea what it was. And this bright spot was still there as the spacecraft got closer and closer and closer, until you could finally tell that it was just actually a very tiny spot that was very bright in the middle of a large impact crater on the surface of this dwarf planet. And since then, Dawn has been studying not only this impact crater, but all the other impact craters on the surface, and has come to the conclusion that the bright spot on Ceres is actually an upwelling, or the leftovers of an upwelling of briny material from under the surface. So just like Morgan was talking about with Pluto, is that salty, briny water is very common in the subsurfaces of tiny bodies in the solar system. And now even something as small as Ceres, we think, has some sort of subsurface, briny, slushy thing.
Really?
Yeah.
So this,
yeah.
I'm showing the picture to the audience at this point. So we're seeing this.
The image you're seeing is a very close-up shot, the closest image that we have of that particular crater that had that bright spot in the center. You can see it's actually a very tiny portion of that crater.
I mean, sort of looking at it, it almost looks like some kind of cryovolcanism. Something is welling up from underneath the surface and just kind of splatting out on the surface of Ceres.
So what they think happened is that about 1 million years ago or so pretty recent in the history of the solar system, is that there was some sort of impact that made this crater, it's a very young crater, which sort of stirred things up on the inside. There was an upwelling of this briny material, which almost instantly sublimated into space and left behind this very, very reflective, shiny salt deposit in the crater. And you can actually, as it was going around, it actually caught smaller patches of this sort of shiny brine material. So to see evidence of recent geologic activity going on the surface of another dwarf planet, I should say, with Pluto, probably suggests that this sort of activity is a lot more common than we might have originally thought. It's not just Pluto, it's not just Europa, it's even something like Ceres.
Just unbelievable. That is one, again, this is one of those mysteries, and I really hope that people sort of see this, right? That when we first saw these pictures coming from dawn, we saw these white spots, and we didn't know what they were, and they were just puzzling astronomers. And now we're at the point where we can see these with incredible resolution, can really kind of study and analyze them, and have a much better sense of the mechanism that's going on. If you go back and listen to old episodes of the Space Hangout, like, you can find the moment where we're like, what is this? I don't know. Right? And then a few months later, we're like, we know a little bit more, but we're not still sure.
We can see it a little bit better, but we're still really far away. And now that's probably about the closest image we're going to get of it. And we still are sort of guessing at, it's probably this sort of briny situation. Yeah. Luckily, Dawn is in incredible health and is going to continue taking more observations, getting more calibrations to improve the measurements they already have, and hopefully we'll arrive at a solution in the near future. But for now, briny material seems to be the likely candidate.
Fantastic. All right, Morgan, let's talk about a weather satellite.
Yeah, that's right. We spend a lot of time here talking about the ability of satellites to look out on the universe, but we often don't think about how important they are looking back at us here on planet Earth. And that's in the spotlight today because tomorrow evening, NASA will be launching a new weather satellite for the National Oceanic and Atmospheric Administration, which is the federal agency here in the United States that handles weather forecasting. And this satellite is provisionally called GOES-R, and it'll be renamed as GOES-16 once it's launched and takes orbit. And the GOES series of satellites are a series of weather satellites that have been studying Earth for the last 40 years. And they provide the data that's then used by weather forecasters so that when you turn on your phone and check the weather, or you watch your nightly news and you check the weather or whatever, all of that data is coming to your country's weather service from satellites like GOES. And this particular one is the first satellite in the next generation of these weather satellites. And it's really quite amazing because every day it will return more information about our planet's climate than all the other weather satellites used by the United States combined. So it'll be stationed to look over the Western Hemisphere, and it will be able to return information about the exact state of the atmosphere, like pictures, measurements, things like that, every 30 seconds, 24 hours a day for its entire projected 20-year lifetime. And so this will give much more up-to-date pictures of things like hurricanes and forming weather systems and tropical storms and things like that. But they've also attached a number of really groundbreaking new instruments to this. And one that's most important for us here on Earth is there's a whole system now that's only going to measure lightning. So it's going to watch, the Western Hemisphere and track where lightning happens, because recent research has suggested that, maybe not surprising, the more lightning you have, the more likely you are to experience a storm. And so for the first time, we'll be able to get real-time counts of lightning strikes all over the part of the Earth that this weather satellite faces. And that'll be a really important variable, especially for things like tornado prediction, because a rapid increase in lightning strikes has been shown to correlate with an imminent tornado. And with something like a tornado, just a minute or 2 minutes makes the difference between evacuating people successfully and having people get killed in the path of a tornado. And so being able to make a prediction just 30 seconds, 60 seconds earlier is all the difference.
So if you want to be able to watch a rocket launch, which now we both have added to our list of, off our bucket list, when's it launching and where can they see it?
So I assume that you'll be able to watch it on NASA TV. It's going to launch just before 6 p.m. Florida time tomorrow. That's Saturday, the 19th. And it'll be launched by NASA and then run jointly by NASA and NOAA. And NASA's getting something out of this deal as well, because another set of instruments aboard this weather satellite is to measure space weather. And space weather is important for two different reasons. One is it can have huge effects on our satellite communications. If you have a solar flare or something, for example, it could knock out part of the GPS system or part of the telecommunications system. And it's important to see these things coming so that your television provider can make adjustments and things like that. It's, of course, also important because these things have deleterious effects on the health of astronauts. And so GOES-R will not only be staring constantly at the Earth, it'll simultaneously be staring at the sun. And it's going to be able to correlate, okay, we see something happen on the sun. And then 8 hours later, we see this thing happen on the Earth. And over time, one given observation of that could be coincidence. But over time, we start to build up, okay, we see these things happening in the solar weather. That means these things for the space environment where the satellites are, and these things for the weather conditions on planet Earth. And so this satellite, which is just the first in a series of satellites that will be launched in the coming years, is going to hopefully enable tremendously improved accuracy to our short-term weather forecasting.
Fantastic. I mean, just getting more and more information about the Earth and being able to see both the weather on the planet and the weather in space. The lightning strike correlation with tornadoes was super interesting to me. I didn't know that there was a connection between those two.
Yeah, that was research that was done here on the Earth just by storm chasers and making counts of lightning strikes, and that's basically been developed to a point where it can now be deployed in a method that will actually be useful for helping save lives here on Earth.
Awesome. All right, Kimberly, we've got one final story about Mercury from you.
Great. So we don't often talk about Mercury.
Mercury?
I'm sad because Mercury doesn't get the love it deserves. Right. So just over, just over a year ago or so, the only mission that we'd sent to Mercury in quite some time, and we probably won't go there again for a while. About a year ago, we smashed the last instrument we had at Mercury, smashed it into the surface. And we were all very sad. It was Messenger, and it was going for over a decade collecting images and measurements of Mercury, and it had well surpassed its mission lifetime. The impact was planned and all that. But we're actually still learning incredible things about Mercury from Messenger data. We're still going through it all. And one of the recent things that we've discovered through images taken by Messenger is that Mercury itself is actually shrinking a little bit, which sort of, I stared at the screen for a little while and I read this and I was like, how did I miss this announcement? This feels like a big thing. And to me, it feels like a really big thing. Mercury is very, very slowly, with the caveat, very slowly contracting because it's actually cooling off a bit. And because Mercury doesn't have plate tectonics and such, as it's contracting, the hard surface of Mercury cracks and shrivels, sort of like if you were to dry a fruit or if you were to scrunch up a piece of fabric. You get ridges and what they call scarps, which are sort of like step-like ridges as they go up. And they actually found very recently through the Messenger images is that there is one of the largest valleys in the solar system on the surface of Mercury because of this slow contraction, which is really cool. It's bigger than the largest valley we have here on Earth, which, if I'm not mistaken, that's the Great Rift in Africa, bigger than the Grand Canyon, still smaller than Valles Marineris on Mars, but that puts it at one of the second largest valley we have in the solar system, and it's on the face of Mercury. And not only that, but it's a recently formed valley on the surface of Mercury, which makes Mercury one of two planets that has recent tectonic activity, the other being us.
That we know of.
That we know of.
Yeah.
That's true.
Yeah. I know there's some really interesting terrain. I think I had a chance to talk to Emily Lakdawala a few years ago, that there's these weird formations. I think they're called them like spider terrain or something. And there's like these strange structures. And a lot of it is this shrinking of the planet, and then sort of structures are kind of collapsing as the planet gets smaller.
Yeah,
So
lots of interesting things are happening with Mercury. And normally when we think of it, we just think of this really hot, dead, rocky world close to the sun. We don't care. It's not habitable. There's no atmosphere. What do we care about it? But there's so many interesting things about it. Magnetic field and the surface features and the type of orbit that it has. So I personally was very sad when Messenger died, because Mercury is pretty awesome. But we're still finding out so many interesting things about Mercury, and now we have another planet with tectonic activity.
And Zapvan mentioned in the chat here that Bepi Colombo is going to be on its way to Mercury. So
I didn't know about that.
Yeah,
one.
it's a European mission. So there
Very
will
cool.
be
Yay.
there's going to be more analysis of Mercury coming. So don't.
I am very excited about that. I personally want to know more about Mercury, because I imagine that most of the exoplanets that we will find they're cold or very hot rocky worlds very close to their stars. Does that do something interesting to the planets? I don't know. So I think studying our closest planet to the sun will really help tell us more about how these types of environments evolve.
Awesome. All right, well, now is the time when we have to say goodbye. And we've reached the end of our stories and the end of our time, and so it's time to wrap things up. But before we do, I want to give our panelists a chance to let us know where we can find some more information. So, Morgan, where do we find out more?
Well, you can follow me on Twitter at Morgan Renberg, or visit my website, morganrenberg.com.
And Kimberly, where do we find out more?
Similarly, you can follow me on Twitter at AstroKimCartier, or go to KimberlyCartier.org, which is my website. And if you want to keep following Tabby Star, again, follow Jason's work on Twitter at Astro_Wright, or the Astro Wright blog, or follow Tabitha Boyajian. There's lots of fun stuff coming up.
Can people still contribute financially to the research if they want to participate? Are there places to do that?
The Kickstarter campaign that Jason mentioned, unfortunately, is closed at the moment, though that campaign only paid for a year of monitoring of Tabby's star. So perhaps after this year is up, there'll be another Kickstarter campaign to purchase more monitoring time. So keep a weather eye out.
All right. Maybe. Awesome. All right, so once again, I'm Fraser Cain. I just want to, if you haven't already, subscribe to this channel. We did a great collaboration with Isaac Arthur just yesterday, where we did the colonization of the solar system. I tackled the inner solar system. Isaac tackled the outer solar system, and it was a lot of fun to kind of work with him on that. And I think it's a much longer episode. I hope you guys will enjoy it. And there's a really cool cameo in my episode at about the 18-minute mark, where a deer walked into the on camera behind me. Huge deer with I don't know, must have been 4 years old. Yeah, it was crazy.
Canada's a wilderness.
Yeah, it really is. You never forget. We have been gone filming and seen a bear, so it's happened. So anyway, just think if you want to watch another show, you should check that out. Thanks again to the WSH crew for handling a lot of the behind-the-scenes production of the show. We really appreciate all your help. If you want to be part of that community, just go to wsh-crew.net, and you can find out more information on how to join that community. All right, we'll see you all next week. I'm going to go to the gallery view. So we got us all here. There we go. Everyone say goodbye.
Happy Thanksgiving if you're in the U.S.
Oh, yeah. Thanksgiving hasn't happened for you yet. Oh,
no.
It's long gone. All right.
Whatever.
Thanks, everyone. We'll see you guys all later.